Five and five, 4, 3, 2, 1. Okay. All right, folks. Welcome to the Docker Networking Meetup. We're going to get started. We have the Google Hangouts broadcast that's recording all of this stuff. Hopefully this works and this is good enough for folks who are not here. If you have any questions, please do stop us and be really loud so that the microphone here can pick your voice up. So with no further ado, Docker Networking Meetup. So we'd like to go ahead and thank T-Mobile, not really T-Mobile, you see the logo over there, but Telecom Innovation Labs, T-Labs. And for those of you who didn't know, T-Mobile is owned by Deutsche Telekom, and so we are also owned by the parent organization, which is Deutsche Telekom. And we are your hosts. They're being nice enough to buy us pizzas, and the reason why we are here and why we have this place is because both Sriram and I are senior network research scientists over here, and we do things related to software-defined networks, and which is why this topic is interesting to us, and I'm sure which is why a lot of you are here as well. So the agenda for the meetup today is as follows. So we're going to talk about very briefly. We're going to start with the introduction of networking for containers. We're going to quickly have a summary of whatever's there on Docker networking page. We're just going to walk through that very quickly so that those of you who haven't actually been familiarized with what's up there can actually see this and get familiar with it. We have Jerome, who's going to join us in a short while. He's going to talk about Pipeworks. We'll then go into a slightly higher gear where Sriram will actually introduce how to go ahead and replace the Docker bridge with OVS and how you could go about playing around with OVS from then on. And so as a part of that, he will also go ahead and give you some basic steps on how to get started right away. So if you have your laptops and you have some of the prerequisites installed, you could also follow the whole tutorial as he goes through it. All right, so let's try and get started. Quick 101. We know that a single host or a server typically has networking interfaces. So that's sort of your ed0 over there. What really Docker does, when you install Docker, you actually have a Docker 0 pop up, and that's your Docker 0 bridge. It's not a normal interface, but it's actually a virtual Ethernet bridge. What it really does is this. Each and every single container that Docker eventually brings up actually has an interface, a virtual VN interface, and it really creates a pair. One of the pair is actually connected to the Docker bridge, and the other one is actually plugged inside of your container. And so this is sort of how it looks like. And because you actually want some form of uniform interfaces inside of your containers, each one of the interfaces that pops inside of the container is going to have the name ed0. And the one outside is going to have a name that the Docker bridge goes ahead and assigns. So that's sort of how it will look like eventually. So just to give you a sense of what how Docker actually communicates, allows the containers to communicate both within themselves and to the world outside. It's typically through the Docker bridge. Having said this, let's actually take a quick look at what are the various options inside of your Docker bridge. Docker bridge can actually operate on a bunch of different modes. As you can see, it's got the bridge mode, the host mode, the container mode, and you could go ahead and say you don't want to use the Docker bridge at all. And I'll just go quickly a little deep into what each one of these are. So when you say bridge, what it really means, that's the default option, by the way, and that's your Docker 0 bridge, the one that I just showed you. It looks a lot like this. It goes ahead, creates the interface Docker 0, and creates the bridge, and goes ahead, lets you, each time you spin up a container, it automatically attaches the interfaces for the container on the bridge. Yes?
Docker 0 is a bridge, config. That's
yes.
Docker 0.
That's
yes.
right. So
right.
When you install
bridge to whatever you want. Usually Ethernet 0 on the host.
Right. So when you install Docker,
right.
You have that interface already configured in your machine. You don't have to even specify a -net bridge because that's the default. The reason you want to have that config is to specify a different name.
Right. As you said, it's not connected to the eth0 of your host. As you can see, eth0 is something else. Docker 0 is actually a separate interface that pops up, and it's a virtual Ethernet bridge. The eth0 inside of the container is different from the one that's on your host, just to make sure that it's disambiguated. And we'll see that in a little bit. For those of you who are coming in, please help yourself to pizzas. And if you run out of seats, just grab those pink cushions that are outside so that you have some seats. All right, so we'll quickly go into what each one of them are, and then we'll go on to the try and answer the question that the gentleman asked. So net equal to bridge is really what we just talked about. If you set it up with the host option, what it means is it basically says, okay, we're not going to go ahead and create a, we're going to have expose whatever is on the host, the interface is on the host, directly into the containers. And that's when you don't actually want to create, have a separate isolation for the interfaces inside of your containers. And that's your host option. Now, when you say net is equal to container, the name or ID refers to the name or ID of the container itself. And so what this really means is you can actually go ahead, use the networking stack instead of a container for another container. So you don't have to go around trying to initialize different networking stacks for each and every single one of your containers. So the goal of this is to try and reduce the amount of networking stacks. If you just care about process isolation, you don't care how the networking is set up, and you have a very specific set of rules for the one single, you've gone ahead, set it up inside of a single container, you don't have to worry about replicating it. And that's when you use this option. When you say net is equal to none, this is essentially what you need to do to be able to get your net equal to bridge features. You don't have to do this by yourself, but whatever you're doing to replace this, we'll have to do some form of this. I'm not going to go deep into each and every single one of these steps. If you're interested, you can grab one of us, offline, and we'll help you. We can walk through the whole thing. It's available on Docker networking page as well. And we'll be using net is equal to none when we actually talk about how we replace the Docker 0 bridge with the OVS bridge. And so you will kind of get a sense for this yourselves. So that pretty much covers your net options. Let's quickly touch upon port mapping and what it really means. So we know the Docker bridge comes up. That's how it looks. So what if you actually are running an application inside of a container and you want to associate the port that the application needs for it to run to a specific port outside on your host? You use the -p flag. The one over here is actually the default flag that you would use. If you specify -P, what it does is it goes ahead, exposes the ports inside of the container to a arbitrary port number that it goes ahead and picks up from the Docker 0 bridge. You could specify a very specific port number as well. And I could give you a very quick example. So let me try and toggle my screen, and let's hope this works, because I have the recording going on. All right, so let me clear the screen here. And let's try this. Okay. So what I did right here, I don't know if everybody can see. Let me go ahead and increase the font size. So what I did over here was to go ahead and say, I don't know if I can. Yeah, does it show? Yeah, okay. Let me clear that up. So when I actually execute this command, what it says over here is, okay, go ahead, associate a specific port, which is 5,000, off the host, to the container port 5,000, and for that specific application. So when I do a Docker PS right now, you actually see that the association that's happened there. So that's the host. It's got the port 5,000 now associated with that specific container. So the -p actually lets you go ahead and specify how that sort of works. The capital P goes ahead and does this automatically. So that's sort of a very quick introduction to port mapping.
Any questions now? Or
yeah. If I'm going fast, stop me. Yes. One Docker 0 bridge, yes. There is just one bridge per host. You could move it to a none option and have multiple bridges. You could have a Linux bridge, you could have an OVS bridge, you could pick and choose, and you could do that. You could change it yourself. But
so you could also do multiple bridges. You can associate any set of containers to a set of bridges, and you could do that. We'll see when we configure the OVS bridge.
Okay.
Most of this may be Greek too.
Okay, that's a good point. I actually have a gentleman here that says that I might want to check with most of the folks if you are already familiar with Docker, because I did jump into this because the meetup, I think we try to specify that, guys, this is essentially not going to be a Docker 101. So I'm assuming most of you guys are familiar with Docker. If not, if those of you who are not familiar with Docker, please go ahead and raise your hand. Okay, all right. For your benefit, we will actually, and if you have any questions, stop us, ask us, and we'll be happy to actually, go into more details. But that's great. Yes. So, okay, there is actually, we will go into more details of the port mapping as well, but I think it'll be a part of the OVS. When we go into the details of OVS, we'll probably see some of that. It is. It is using IP tables, yeah. So we will actually have, during the demo, I think we'll have an IP tables list. We will be able to actually see how that port mapping happens for each and every single one, the accepts and the for the post-routing tables that you'll be able to see.
You want to add something, Shri?
Yes. Do you have a question? Okay. All right. So let's go into the, okay. So one of the common requirements of, the things that you would want your container to be able to do is for it to be able to go out to the internet. And the requirement for that is that your host actually needs to have an option, which is called IP forward, to be actually enabled. Because what's happening really is that your host is sort of acting as some sort of an interface where it's going to go ahead, pick up traffic from your containers, and then pass it along outside, and do the opposite as well. So to be able to do that, it actually needs this particular flag to be enabled. Now, when you install Docker, by default, it goes ahead and enables this, this option. And when you bring up your containers, you have a couple of flags that you could set to allow the containers to go ahead and send traffic outside or not. And that could be set using, let me see. Oh, there's an IP underscore tables is the flag, hyphen IP tables. And so if you set that to be equal to true, it will go ahead, it's true by default, in which case we'll go ahead and set up all of the IP table rules required for you to be able to access the internet. The second question that typically people have when they're running containers is, how do we actually use this to communicate between containers? And so that's sort of your inter-container communication. And you have another flag to be able to go ahead and enable that. So some people think of this as a security issue as well. This could possibly be a security risk because you have multiple containers running. One of them have permission. So people generally prefer to run this with the flag set to false. So they don't actually enable ICC. So what ICC really does is, again, like we talked about before, it goes ahead, sets up the IP table rules that allows each and every single container to talk between each other. And when you set this to false, it says, okay, no can do, or they're not going to actually allow any traffic to pass between each of these containers. But then what if you have a requirement where you do need the containers to talk among each other, but it's not a general policy that you want for all of the containers? So what Docker really provides is another mechanism called linking of containers. And so there are two steps to actually enable or allow linking of containers. And the first one is you have to go ahead and name the container using a --name option. And the second one is essentially going ahead and when you run the process itself, you can go ahead and give the link option along with the name and the alias. So let's take a quick look at how this works. I have a very specific example that we can look at for linking. So what we're going to do is we're going to run a Docker container that uses actually Postgres. We actually have that already running up there. That's the container that we're going to use. It's actually named DB, as you can see, for database. So we're going to go ahead and try and link this with a web tier one. So let's try this. So I started another container. I gave it a name web, and I asked it specifically to link the DB, and I gave the link itself the name DB. So this is the name and the alias, the link alias at this point. And I said, go ahead and do this linkage. And when I do this, I can now go ahead and list all of my containers over here. And as you can see, when it lists all the containers, these are the lists. There's one called web, there's one called Penguin, and then there's one called DB. but it also tells you how it's linked. So web and DB are linked together. Now, what does this really mean when we say it's linked together? So this is sort of what it is. It essentially establishes a secure connection, a secure tunnel on top of the Docker Zero bridge that allows each of these to communicate with each other. There are two additional things that happen. One, the environment variables inside the second container that I started. So I had DB already running, and I said I started up web and I connected these two. So it goes ahead and sets up the environment variables inside of the web container and says, okay, here are some of the variables that are going to give you information about the DB container. And it also modifies the etc/hosts file to actually include the IP address of this container and the host name. So whenever you try to actually access DB from here, you could just use the name alias. You could just say ping DB, and it would work just fine. And so these are the two changes that happen when you actually go ahead and do this. And it uses the tunnels, the secure tunnels between them. So now the reason why people actually like this feature is because let's say that you actually expose your web container to the outside world, and you don't want to actually expose your DB. This could be one way that you do that. Yes. Go ahead.
Can you get into the web container and show IP address and try it out?
Sure. Yeah. Let me just get into the bash for this.
So now you're inside the container?
Yes. You could explain to it. Yeah, that's just, so what we're doing over here is we're executing a bash process inside. And so when we do that, we actually drop inside of the container itself. And so we're now inside of the DB. Let's take a quick look at this. Let me show you what the host file looks like. Oh, actually, we want to be inside the web. That didn't work. Partition the terminals would be. You just want IP address? Okay. I have actually, I don't know if I've installed all of that. Let's see. All right. So that's your Ed0 that's configured over here. So you want to actually see how this is actually, so you cannot.
No, just an IP route.
Yeah.
IP
Okay.
space route.
So for a lot of these things, okay,
Okay, that's it.
yeah, so it just has the 17 address. That's your Docker Zero bridge address, and that's all it has. It has nothing additional to that. Does that answer your question in any way? Okay, all right.
Are these right?
These are, yes. Sorry, what is, I didn't get that. Yes. Okay. The service is running on the host that you want them to be able to communicate with the container. You'll have to actually treat the ones in the container just as you would as a separate host. So it has its own IP address, and you could actually just do the regular communication as you would. Do you want to actually use the linking to be able to communicate with the process? Yes. It doesn't actually affect the services per se. I mean, you could be running whatever service you want to on the host. I mean, if there's a dependency on the IP forward flag, then sure, yes. And if you have, I don't know, a firewall, if you're running pfSense that requires that IP forward not be enabled, then it's going to probably violate some policy inside of that, yes. But is there any specific service you have in mind? There isn't. Right. Right. So if the ACLs are associated with MAC, like I said, I mean, if there is a dependency on that forwarding, then you will actually have a problem. So in the host, you will not be able to configure something for each and every single container. So if you want something specific for a policy and ACLs that you want to specify for a container, then you would actually have to do that in the IP table rules that are for Docker 0 bridge. So you would have to specify ACLs for Docker 0 in some sense, and then associate it with the IP address itself. Does that make sense? Okay. You can. You can ping it, but I don't think that's sort of what he meant though.
Yeah,
you reach it because you can reach it as a first class citizen. I mean, you're using the IP address to actually reach it, but there isn't any kind of an internal linkage that you can have between a container and the host. You can have it between containers, but you can't have it between a container and the host.
I can pick from the host to the container.
Yes, you can, and vice versa as well, because you're just using the same. Within the container. Between containers, yes, you can. But for that, you actually needed to have enabled the inter-container communication. If you don't enable the ICC flag, then you're not going to be able to actually have any connectivity. Even though they're all in the same bridge, you will not be able to ping them. So the default option when you bring up each and every single container, it sets that ICC flag to be equal to true. So that's why you're able to go ahead and ping them all. Yes. Yes. Yes, they are. Well, it's just secure in the sense that the tunnel that's created is a point-to-point tunnel, and so if you're actually trying to expose the other, I mean, it's not you cannot actually access either of them because you've disabled the ICC flag. The only way that you can ping them is because there is the configuration. You have the under the etc host, you've gone ahead and set up the alias, and that's how you have the IP addresses exposed. So the secure. So, I'm sorry. Traffic is still going. It's not encrypted. It is not encrypted. So I mean, from the bridge, you can actually still see it. All it is it doesn't expose the endpoints. So from that perspective, if you were to actually bring up yet another container and try to actually sniff on the traffic on your bridge, you'd probably still be able to listen in on the conversation. So there is there's already a pull request that's come in to actually set up secure tunnels, which is why I think I said that. So there's already a pull to actually do the encryption on the tunnel, so that whatever you're sending using linkages will not actually be visible, even if another container comes along and sniffs on the bridge. But it's not there just yet for the example, but it will be pretty soon. I don't actually. I just know that there's a pull request. So yeah. The link command symmetric in this sense. Yes, it is. Yes. Go ahead.
So once we go into the advanced, I'll explain that as the first thing. So
it does.
It does.
Yes. No, it is. I mean, it does actually show up even if you go back into the other one. Yeah, I actually logged into the couple of containers that I'm running with similar names, and so I logged into the different container, but it does actually show up on either of the cases.
Can you actually put the 0 interface relative to the container and a promiscuous load from within the container? So that you can sniff traffic inside that container on the interface?
On the Docker bridge, you can, yes. For that, you actually have to. It has to allow the inter-container communication.
Does that require the privilege flag?
It does require, yeah. The ICC requires a privilege flag, so automatically you will be able to actually then switch it to promiscuous mode. Okay. All right. Let's go to the next slide. What do we have? Okay. Quick, for those of you who want to actually do the hands-on, demo that Sriram has, please go to this page really quickly because the setup time takes about 10 to 15 minutes. And by the time we have other folks talking about the remaining stuff, if you get this process started, we'll hopefully be ready by the time Sriram comes along. So if you could just go to this address, we'll give you a few more minutes or a few more seconds to actually get there. Easier?
Do we have a Wi-Fi?
Oh, yes, we do. So,
I'll give it to
okay, great, thanks. Yes, you do need it. Okay, let me actually go ahead quickly switch back to the first slide. For those of you who need the Wi-Fi, that's your SSID, that's your password.
What was the link?
Oh, okay, yes.
Is that just install the background?
Vagrant.
Yeah,
Yeah?
yeah,
That one?
yeah. You got the
Not good.
background installed, and then you also, there's also a Docker, there's another container setup stage. So let me actually quickly toggle back. Has everybody gotten the Wi-Fi passwords and the login? Okay. So we'll go back. Okay. It's bitbucket.org/snrism/container. That's your. That's my. Okay. So if you go to that site, you will actually see a README page on the Bitbucket profile. There are two sections to the README page. One is the installation, and the other one is the container setup. For those of you who already have, Docker running and you have a couple of hosts separately, you can ignore the first step. But if you don't have that, then grab VirtualBox or Vagrant from here, and then just follow these steps. So we will walk you through these steps right now, so that you can go ahead and start the setup process. If you have any trouble, just go ahead, raise your hands. We'll come to you and help you.
Yeah, I'll get posted.
Okay. You want to? Okay. Let me actually put that up on it.
Sorry, what was the question?
Somebody had a question.
Yes. Yeah. Thank you.
Yes. For those, it is also on the meetup page. You can pull up the link from there. So the Vagrant actually hosts have it. So if you grab it from the Vagrant, if you actually grab those images, they already have them loaded on it. So it should come up. Yes.
So I'll just walk through what's in the source code.
There you go.
So, folks, here we're going to actually do two set of experiments. One is use the Docker bridge as well as use an OVS bridge and connect two hosts. The other one is get rid of Docker bridge, use just plain OVS to connect these containers. We have a Vagrant file set up. So if you see in the source, so it's going to configure the two hosts for you. So the gentleman who asked about that. So why don't you just go and do a git clone on in the repository, and then just pull the code so that we can go over it.
Yes.
In your
Docker Zero Bridge with OBS. Yes.
So
Yes.
no,
No, not wait.
OBS is running the kernel
OBS
space.
is running on the kernel space. Yes. It's not user mode OBS.
There's an option if you want to run OpenVSys inside a container as well, in which you would set up routing and stuff like that.
Right. So that would be running OBS as a container itself.
Right.
Yes.
So that, so folks, you can just do a git clone on that link. You'll be able to get the scripts that we're going to run through. So once you do that, you should have these set of scripts in your machine. So once everyone is on page, we'll move to the next.
Yeah.
Do the instruction for this one.
So
Which one?
This
as
is
part
again
of the
the same.
instruction, this is the first step. That's why it is.
It's the, no, this is for those who already have Vagrant set up and they just want the Vagrant file. While people are just going ahead and installing, it would be great if we could just go quickly around the table and do an introduction. I didn't do this at the beginning because I figured everybody would be spending some time trying to get the installation going. But it'd be great right now if you could just go ahead, introduce yourselves. We'll start from the gentleman right here.
Jerry from
Listen from hotel search. I'm training with the car.
I'm Mark Bobby from Katrina. Folks, there's a chair there and a chair there. If you want to come in. And with Katrina. That's the Katrina. Training from Nixon.
Dan, I'm a freelancer.
What do you mean? John from Bible. Bharat from Katrina.
And we have the gentleman in the row. You're the special guest. Go ahead.
David from online.
Right. Right. Thank you. So I hope you guys are making some progress as far as the setup goes. Let me toggle. Did you want to actually? No, I mean we're just going to go through the whole setup so that people have the environments going.
So just to let you know, the
Yes.
download is like 200 ASM.
Oh, that's low.
That's really bad.
It's pretty bad. It's not going to take.
Yeah, we were initially sorry that we posted the link a little late. If by any chance, like if not the downloads are not happening fast, you can look at the demo. The README is there. You can try it out later. That's probably the best option in case. Okay.
Okay, so it's got. Yes. So we're planning to actually give folks a local job, but we're having problems with our network. That's why we are on a different wireless network, so we're not able to access those right now. Right. Yes. I mean, we were hoping that it would be fast enough, but yeah, you're right. I think it's not just the Wi-Fi that's slow at this point. I think it's also the downlink in itself. Yeah. So do you want to just go ahead?
So download this.
Yeah. For those of you who are actually trying to download the VBox, the Vagrant box, you could actually just grab it off of this local drop as well.
Yeah, this will be faster. So
Yeah, you can just go to plabs.us/temp/docker, and then you can just go ahead and download your box file from here. And so when you're doing your Vagrant setup, you could use this link as opposed to just using the HTTP link that's there as part of the tutorial. So okay, let me actually.
I have.
So let me. I think I'm pretty much done over here. I think I'm just going to hand off to Jerome. I think I have a thing from him on the phone. So let me go talk to him while
Okay.
you want to start talking about the OBS
Sure.
piece. Sorry. Okay. Yes, you need two for following some of that. So if you can actually just go ahead, snapshot that into another VM, then you could have two. Okay. So I'll let you get started, and then I'll go talk to Jerome. See where he's at.
So folks, I mean, hands-on is not working if the links are slow. We'll see the demo. We'll go through every step. You can try it out later. The README, the installations are all going to be there. So
Yeah.
let me quickly.
The Hangouts on air is happening here, so if you want to use it. The Hangouts on air is on this one.
Oh, okay.
So if you don't mind.
Yes.
I'll just toggle really quickly. Oh, you have your script on there? Never mind that. Just go ahead. I'll just actually switch to the video. Don't worry about it.
Okay.
Go for it.
So one thing, till now, what DJ was talking about is particular to a single host or single server. So if you install Docker in one particular machine, you can start your containers and it's going to work pretty well. But think of what's going to happen in two hosts. So for example, if I'm going to start two hosts and then install Docker on it, the first problem that you'll notice is both Docker bridges get the same IP. And then when you start containers on top of it, you could have conflicting IP addresses started on those machines. And if you want to connect them, then there's a problem. So sure, but you have to have different networks. Yeah. Why would you want to do that? Right. But okay. So what I want to first show you a demo of is let's see this. Like to make sure that this IP address conflict is happening. Let's figure that out. I'm going to run the same instructions that's there in the README file. You can try it out later. I'm trying to bring up two host machines. If you're lucky, the Ubuntu server is already in my host, so it's going to cache that and then get that information. So this is what you'll see when you run the README, the instructions in there. And this is nothing related to Docker as such. I'm just setting up two VMs using Vagrant, and I'm just going to configure that. I'll just show you the Vagrant file. So if we go check the status. Okay, so we have two machines two VMs that are being configured. Let me quickly open the Vagrant file to show you what is in that machine. I'm starting an Ubuntu Linux box inside that, and then I'm going to configure it with an H0 interface, which has this IP10, a private IP address. And then what I'm going to do is essentially run the scripts that I've downloaded from the host. I'm going to share that folder into these guest machines so that we can run the script from the guest. So that's pretty much the config that we have for Vagrant. Let me start the screen. To the machine, we're going to run a lot of privileged commands, so I'm just going to do a sudo. And you see that Vagrant install had an interface by default, and the F1 that we specified has been configured inside that, so we're going to use that. So since I have a shared folder from the host, it's in that meetup folder, and you can see all the scripts are over there. I'm going to do an install. So what this installation is going to do is essentially install Docker, Open vSwitch, and Linux Bridge in that guest machine, and it's going to configure Docker by default for you. Okay, I'm going to do that same thing. In the other host. Any questions so far? Oh yeah, sure.
Go slower.
Sorry, guys. We should have. We initially thought of snapshotting it, but we didn't get to that state. So we'll do a better job next time.
Ask you a question.
Sure. Yeah.
Does the Docker more VLANs? So if I do VLANs,
We're going to see that. Yeah. So what you can do, spin up containers, and now that you've installed OBS to OBS, you now have whatever you want to do with OBS, you can do that. So now you could isolate containers. You can configure different containers in different VLANs, and so they can.
And the duration that it's taking is you could just walk through all of the experiments that you plan to have.
Yeah, that's a good idea.
Yeah.
So what I'm trying to go show here is first we're spinning up two machines. We're going to spin up the containers. You'll see that there is IP address conflict. So this is one reason. Maybe you don't want to use Docker as networking, but I'm sure they're fixing it. Jerome, when he's here, he might give us an update on what's the current status. So then what I'm going to do is I'm going to take control of the networking configuration. So when I start all my containers, I'm going to use a net none that DJ specified, so that now you have complete control of it. And then what I'm going to use is the script that we have. When we start the container, we determine the IP, the container ID from the running container, and then specify the IP address. So that you won't have the isolation, but you have now the pain of configuring these IPs with on your own. Then we're going to see connecting the OBS bridges to the Docker. This is just the first step before we get into just plain OBS. The idea is to show that you could run multiple bridges. I think there's one question on the host and then connect them. So it's more like a virtual grouping of these bridges and containers. It's just an extra hub. Think of this as two switches in your host that you want to host. And we'll set up a GRE tunnel between these two hosts. And now when the traffic is routed from the containers, it goes first hits the Docker bridge, hits the OBS bridge, and then gets it. Which is complicated. We don't want to do that. So we'll get rid of Docker, and then we'll just connect the containers directly with the GRE to the OBS. That's what we have in store. Let's see how it goes. Okay. So right. So since we are now setting up a GRE tunnel, we don't have to associate that IP, configure the IP address to the OBS bridge. What I'm going to do is set up a tunnel. So I'm going to get the remote IP of the other host and configure it with this GRE. So that normal. Yes. You just start your tunnel with a GRE.
Because the default route, the default route for container was Docker killer.
Right.
But when you replace it with OBS, what would be the default?
Right.
So because the OBS is not connected.
Which is true. Actually, we have actually IP table configurations that we will walk you through on a step-by-step basis, and you'll be able to see it. Yeah.
So next, what I'm doing once before I do this, I'll show that Docker is installed in the source machine. You could see that both the hosts have come up with the same IP address. Let's do this. And so that's not a good deal, because if you're going to connect this, you're going to have issues. So what I'm going to do now, before I even go and muck with the networking piece, I'm going to pull an Ubuntu image from Docker registry. Do you want to talk a little bit about Docker registry?
No, it's okay. I mean, I guess most people are familiar with the Docker registry itself. It's basically a repository. Think of it as a GitHub of some sort, where it actually stores all of your Docker images. And these are your base images that you would just go ahead and do a very similar operation to a Git clone. You would actually just go ahead, grab the image from the Docker registry, and then you would build whatever containers you want to using the base image. And so he's right now just going ahead and downloading a basic Ubuntu image. And we'll actually go ahead and, as we spin each and every single container, we'll base it off of that base image and add additional things on it based on the Docker files.
That's right. So Docker claiming to be lightweight, there's one thing that we noticed, Anirudh, my colleague, and myself were trying out. We saw that since it's based on an AUFS file system, it tries to retrieve this image from the registry, and then it kind of combines, more like getting it from different sources, and combining and wrapping it up and setting up that image in your machine. So what this is going to do is essentially doing that is pulling up the Ubuntu image from the Docker registry. And I've also installed a ping and IQF inside that image, so that when you boot up, you have that option to just test out the ping that you have. Same old boring ping, but at least that's the stuff.
The bane of all network engineers is that our best demo will actually just have a bunch of CLIs popping things back and forth. Yeah.
That's right. So whatever I'm doing in a single host, you have to repeat the same setup with the other one. So as you can see, it is completed downloading the image, and then I've done an apt-get update, so it's going to update and then going to install the packages that I've asked for. So the way it does that is, I have a Docker file. It's more like a config file in that host. It's going to, you can specify what you want to run in that image. So it reads from that Docker file, like how Vagrant has a Vagrant file, Docker has a Docker file. So it downloads and basically executes those instructions sequentially and then installs them. Right. No, this is different. So the idea is to think about hosting your Docker containers in a GitHub. So they have a Docker registry. So if you want to share your containers to the public, so you basically host your, yeah, that's the idea. And in fact, one of these images could be hosted in.
There are private registries as well that
Right.
you can use, and pay some money to make sure that whatever you're putting up there is private. You know, if the setup you have your own, you could actually swap.
Oh, I see. Okay.
Or you could finish up the first experiment.
Okay. We'll do the first experiment and then. Yeah.
Is Docker's networking different than any regular container networking? Linux?
So Docker evolved from Linux, if you think about it, right? And then what happened is they now moved away from Linux containers to having their own base implementation to lib containers. So there are public folks who are contributing to the base implementation. So in that sense, they're adding new features where it could differentiate what you get from the regular Linux.
I mean, not about specific tools and syntax. Looking about the state of mind of doing networking, is it the same Docker as in any other Linux container?
Absolutely. There's nothing that you get extra, just that there is an API for you to play with your containers.
So containers from other companies will have the same networking like this?
It depends, right? Like if there is a private company which has its own.
If I may just jump in there, so it depends on the kind of APIs that they're providing. So far, I think Docker has made its way in terms of trying to provide a lot of these APIs that you just saw, the flags that you just saw. If you want to be able to go ahead and set up a default bridge, you just go ahead and say, net equal to bridge. I mean, it's basically the extensibility of that. So LXC by itself does not provide you with a lot of those things. So I showed you a very brief example of when you say net equal to none, there's a whole lot of commands that you need to be able to run to be able to actually just get the same feature as you would if you just specify, hyphen net equal to bridge. So you would have to do all of that yourself. You would have to create the virtual Ethernet pairs. You would have to actually configure the IP table tools yourself. You would have to do all of that. Sure, I mean, if another company starts serving their containers and they actually do all of that themselves, they look a lot like the Docker container.
So, yeah. So the image has been downloaded. What we're going to do now, to get the context, we're just going to start the container without using the Docker's native networking. We're going to run a set of scripts where it will install the set up the GRE tunnel and then connect it with the Docker. So there are two folders that I've created. One is to run the first experiment where you'll have both Docker and OVS, and the next one is just using plain OVS. So do that. So I have a set of environment variables that you can set, which is in the scripts that just go ahead and configure that in your machine. So once you do that, you run the OVS tunnel. This is going to set up the GRE tunnel, restart the Docker daemon because it's now attaching the OBS to the Docker bridge. We'll do the same thing here. Okay, so now let me do show. So the GRE tunnels have been set up, and so if I do the regular VRCP command, you can see that the Docker bridge is still hanging there. You configured OBS. You now take in the OBS bridge and then connect it as an interface to the Docker bridge. I'm going to do that. So for Docker to actually, for the containers to actually talk to the outside world, we need to play with some, we need to set up some IP table rules. I'm going to do that. And then it's time to start the container. So let's see. For the Vagrant VMs,
Yeah.
you don't actually need to because it picks up from SSHD. Are you having trouble with that?
It's not typically the login and password are needed. Try that, but it should not ask for it.
Did you actually have the default
I did. No, I mean I didn't use a password. Right? It is
So
configured.
it's the default.
Yeah.
In that case.
So let me. So what I'm doing here, I'm spinning up some containers without using the networking piece because I'm just doing it. If you look at it, there's one container that's already running here. I'm going to do that in the other one. Use the Ubuntu image. We have another one. Both these containers started. So let's start the container without and configure the IP addresses for this. So, when the Docker container starts, you can see that it throws out a container ID, which you're going to use that and configure the IP for whatever you want.
Yeah, crazy.
Oh, I see. So okay, let me do the other one also, and then I'll explain this one. Okay. I will run the start stuff. Okay, so now we have two containers hosted in two different machines where it's being configured with our own IP address that we have specified, and then let's try to think. Okay. So just to check that nothing else works. There you go. So what we essentially did is kind of repeat what Docker does when we run its networking piece. But then we saw that the IP addresses conflict. We don't want to, when we spin up Dockers on 2 host machines, you want to take control of the networking piece and configure these IP addresses. So before I jump into the next one, we'll have Jerome here, and then we can continue after this. Yeah. That's right. Even Docker does the same. So the only thing is that when you spin up the Docker container, it magically sets up the IP tables required for you to reach. Also. Sure. So let me exit that. And then you'll see a bunch of oh, yeah. So you can see that the Docker is now configured with the IP address that we use. The BR0 is the OVS bridge that we have. So now the Docker bridge is connected to the OVS bridge. The OVS has a GRE tunnel with the other hosts, so it doesn't have that.
Right, we have Jerome from he's the author of PyTorch, and I think he's dead actually. There you go. All right. He's going to talk about how essentially a part of how PyTorch actually helps replace the Docker Zero bridge. Do other cool things.
Oh. So some of the stuffs that we tried out, we have Jerome's blog, which explains to set advanced network configs. I guess Jerome is going to explain that. And we'll also ask him how to actually configure IP addresses when you start containers. Is that going to be in the future releases?
All right. Well, hi. So thanks a lot for inviting me to talk so that I could present this. I was thinking initially, I asked if I could be present for the meetup because networking Docker is really one of the things I enjoy working on. And so I think we kind of misunderstood and it was as that I said if I could present instead of be present.
So we actually didn't misunderstand. We actually didn't misunderstand. We really wanted to get use of this guy when he's here.
So PyTorch, the little so-called defined network container framework that we should not use, and then we explain kind of why. I always love to have some kind of shocking sentences like that. So why present something that we should not use? So PyTorch, nice picture of some Google Data Center. Short presentation, but as you can guess from my accent, I'm French. I try to run everything into containers. That involves running firewalls, running routers, and things like that into containers. And specifically that area, when you use the default network model, it kind of doesn't work. You just have one interface, you can just connect to the ports. So we needed to have something else. So short history of PyTorch, so why I got that in the first place, some of the features and the roadmap. So the use cases for PyTorch were initially performance, integration into existing network, like I have some service that I want to put in a specific VLAN, or I want to use bonding. I want to use something that I already have in my network, and how can I do that with Docker? And it will also to help to work at level 2 or level 3. So think as a container as being connected to an Ethernet local network or into an IP network with an IP address instead of level 4. Currently, by default, Docker is level 4. You expose a TCP port or a UDP port. You don't really expose a container with IP address. Some people want that. And there was also the performance side of things. And really is that initially, when I did the first version of PyTorch, it was really a hack. I mean, it's still a hack, but it was even worse of a hack. And it was about 1 year ago, and I was invited by Yandex, the Google of Russia, to speak at one of their big tech conferences. So basically, the Google I/O of Russia. And they took me to this bar before the conference, and they got me to sit. They brought some beers, and they told me, okay, how do we get good network performance with Docker? Because we're using Docker, we love it, but there is a little problem. We want to be able to send like tens of thousands of requests per second of traffic per container, and it just doesn't work. So how do we do that? So I started to explain, well, you can take an interface and move it from one namespace to the other, and you can achieve this and that. They were not convinced, and I had this little script that was doing exactly that, that was taking an interface and putting that in the container so that the container could have direct access. And so I said, okay, wait, guys, I get my laptop and I start to make a short demo, and they started to speak like to each other in Russian, and that's when they decided that they could use Docker for their production traffic. So it was kind of a good news, and that gave me the idea that yeah, I should maybe continue to work a bit of PyTorch because you could get people like that with big workloads to use Docker. Good question.
Can you explain why Docker without PyTorch instead?
So it's not that slow. I mean, for many people, it won't be a big problem. There are multiple performance issues that can arise. One of them is linked to the Linux bridge. So I know a little bit of the technical details, but not a lot. Someone that know really the internals of the Linux bridge, maybe would say that I'm just seeing wrong things. But if I understand correctly, one of the issues of the Linux bridge is that it's kind of single-threaded, so it won't be able to use multiple cores. And so at some point, you're just limited by the number of packets per second that you can move from one port to the other. That's a problem that you don't have when you switch to the open vSwitch bridge instead. Another problem is with IP tables, because IP tables will do connection tracking. So each time you have a new connection, you create an entry. And even though IP table is extremely fast, it's still not that fast. So when you're talking about tens of thousands of connections per second, then the overhead of just looking up, oh, is this a new connection? Like hashing the source and destination IP and ports and checking in the connection table, is this a new connection? If yes, let's NAT it correctly. If, well, does it exist? Is it new? Add an entry, lookup, etc. That takes some time compared to just making a simple routing decision. It doesn't really show up for a few megabits or tens of megabits of traffic per second, but when you get to gigabit of traffic per second, and especially small packets, because the throughput is not really what matters. What really matters is the amount of packets per second, and then things can get pretty bad pretty quickly. So does that answer the question? Yeah.
One question is regarding applications for the session. You don't have to do that. But I guess there is a reason why Docker's implement applications with contract or
right.
What is the reason?
Because it was the simplest thing. The idea was to have something that could work on public cloud. So on public cloud, you typically have only one IP address per instance. So we can't just say, okay, let's put one IP address, like public IP address for each container. We had to have everything behind the IP address of the machine. So we had to use an internal network. So we had to use some kind of address translation at the port level.
But that is static address translation should not be contract. 44 is going to not be state.
Right.
But it's state
yeah.
for pet.
Yeah, precisely.
Where's the pet inside of it?
The why port address translation? Or
no, when you have a static 44 translation,
right?
Because it states. Because always.
Well, you still well.
It's the statistics that are stored for each and every single thing, even for the static port mapping. You actually have counters and packets. I mean, you have additional information around it that you still have to store. There's some amount of state that's still stored even for static.
Yeah, but not creating a new state for each new connection. Doesn't have to, but it's static.
So you can simplify the things if you use
right.
Theoretically,
asking why Docker implement that
Because it was the simplest thing. Using IP tables rules was the simplest thing, and as far as I know, you can't do port address translation with IP tables without keeping state. I think you can do that with IPVS, maybe. And we are thinking about, hey, can we just like throw away IP tables and use IPVS instead because it would be better, but it's still like a discussion, but it's not happening yet. But yeah, it was really because everybody knows IP tables, and so well, everybody knows, not really, but more people know IP tables, so it was easier to have something that works. But yeah, that's a good point. So how pipework works? Yeah.
It's recording the
Right. So maybe it should move away a little bit. Sorry. So it creates a network interface on the host, and then it moves that network interface inside the container. And it can do that in many different ways. It can take a physical interface and put that in the container. It can create a MAC-VLAN interface, which is a kind of sub-interface to simplify things a little bit. And then you can put your container as if it were connected to your physical network. And it can also create DETH pairs, so pairs of interfaces, one being on some bridge somewhere and one being in the container. And it's a shell script. So people ask, why did you write that with a shell script instead of using a real programming language like a real programmer? The point of using a shell script is that it's really easy to understand. Even if you, I mean, it's already pretty difficult to get the basics of how networking spaces work, how you can move interfaces from one to another. It's a perfect challenge. So if in addition to that, you have to do all that thing with netting code in C or Go or Python or something, it just adds a lot of complexity. And also, most of the things that Typework does are like calling binaries like IP, VRCTL, vconfig. So writing C or Python or whatever just to constantly shell out, that seems to me like not really necessary. And also things that, so some people ask me, okay, can we have like IP address management? I want like Pipework to assign IP addresses to my container. I mean, as automatically, like I use Pipework on 10 containers and it gives them 10 IP addresses just like Docker does. No, that's like out of the scope of the project. And using shell means that you don't try to make so some examples and features. So you can start a container and you like that's using a MySQL image and we name it DB and then you give it an IP address. So the key idea of Pipework was to find a syntax which would be ridiculously easy, so that anybody would look at it and say, okay, I can understand more or less how it works, and not something like QEMU and for TDM networking, would be like -net init, -net user something, comma, some weird option, and you have to read the manifest 10 times to figure out how it works. Obviously, this is much less powerful than the QEMU or TDM networking stacks, but yeah, for something similar. So in that case, I say, okay, I want the MySQL container to be connected to ETH0, which will automatically use a MAC-VLAN interface, and I give it an IP address. And if I want to connect that container to a bridge to make a private network between containers, I just give the name of the bridge. I think if I just put like beer something, it will be smart enough to create the bridge. Not sure. I can use an open switch bridge if I have that on the machine. I can also, instead of specifying an IP address in the command, say I want to use DHCP, I can put the VLAN tag number. So that's the kind of short list. So addressing the MAC address, you can also change the MAC address if you DHCP, that's convenient. You can change, there is a weird syntax, so you can change the default route if you want to do that. You can use the Linux bridge or OBS bridge because the tooling is kind of the same from Pipework point of view. Someone just sent me a pull request to do IP over ID, so to use InfiniBand interconnect and to do IP on top of that. And I haven't clicked the merge button yet, but we'll do that later today. So it's as if it will. And you can add multiple interfaces in a container.
So, I have a question.
Yeah.
So with respect to OVS configuration Pipework, can you does it allow you to configure OVS set up different tunnels, or is just attaching the container to the OVS bridge?
Just attaches the container to the switch.
Okay.
Yeah. There are many things that will deal like with tunnels and the real hardware. Here the idea was just okay, let's connect the container to this existing switch.
So is it correct to assume that Pipeworks works great for a single host? Can I do it for two hosts?
So when you want to connect containers on different hosts, the idea is to, for instance, use the ETH syntax like that. So you say, okay, now that container will be directly connected to ETH0, and I can have another container on another machine connected on the same Ethernet, and I will just give it an address, and that will work. Typically, if you want to do that, you want to use the HTTP because if you start to assign IP addresses like that yourself, you will probably shoot yourself in the foot. It's exposed. So basically, that the container will have a new interface by default to the ETH1. So it keeps the existing connection, but it adds a new connection, and it's exactly as if this interface was kind of hooked in parallel to the physical interface of the machine, or virtually, it's a VM. And then I can, from the container, I can send traffic from 10 something, and it will go over the physical network. So plenty of features. Now, what about the roadmap and the future of Pipework? So this is the roadmap. So we realized that pretty early that it would be extremely difficult to integrate Pipework into Docker because, well, obviously it's shell, so that's not a good starting point. But also because it doesn't really fit the way that we work with the Docker API. With Docker API, you start containers, you do everything with the API. Pipework is something on the side, so it just doesn't really fit in. It's convenient. It helps many people, so that's great. But by itself, it doesn't have a bright future. So why the recycled bin? The idea is that it's great to have Python as a kind of toolbox, and when you have some network special thing to do, you can test if it works with Python. And if you find the right configuration that works for you, it's a script. It's pretty easy to find out what it's doing, and then you can whip out the bits that you need and put them directly in your container orchestration system. So yeah, will not be integrating Docker. Also, some of the use cases like performance are now addressed by the host networking node. So the people who think, okay, we need to be able to fill up like 40 gigs per second of traffic from containers, now they can use Docker run that -net host and they can achieve that. So those people don't need to use Pipework anymore. It's not actively maintained. It means it's passively maintained. Like I try to at least once a week, but sometimes it's less frequent than that. I try to check the requests and issues that people are sending. If it's issues and questions, I answer them. If it's pull requests, I try to say, you have to put a comment here. I do really basic review, but honestly, we did that where the bigger and more kind of service project. We will need tests, we will need proper release cycle, with version numbers. Currently it's just a shell script. I'm happy to merge pull requests. It's actually extremely exciting when you have started to write something and people contribute features that you have never thought about. But I'm not really actively working on it, unfortunately.
Good question.
Yeah.
You mentioned a performance, so
Right.
are there any efforts with Docker to integrate natively with GDP? You mentioned the host.
Okay. That's an excellent question. It should be possible, and when we were talking at the last meetup in Chicago, I tried to talk with the Melanix guys and some of the container guys to see, okay, we used to say that userland networking is a bad idea until stuff like DPDK and something. So that kind of changes the deal. It's like, okay, now we can actually do username networking and containers might be a very good fit for that. I think Pipework really plays a new role there. But I think it's it's a really exciting new direction to explore.
What are you doing it?
Not, but yeah, it's
So yeah, as I said, the idea of PyTorch is that it's a big toolbox with many use cases that are useful for people. But I don't expect people to really like use PyTorch in production, but rather to find out the bits that they need and integrate that with their existing tools. Possible improvements like at some point, if I find a way to not need to sleep, I might be trying to work on a variation of PyTorch. The idea is that there is a way to do all the work of PyTorch, so setting up those interfaces and everything, only through the Docker API. And then it means that PyTorch suddenly becomes a little bit more interesting because some of the big problems it has, like the fact that you want to run it in the host, the fact that, for instance, for DHCP address allocation, it relies on the DHCP client installed on the host as well. So if you don't have one, you can do DHCP. There are little things like that that cause bug once in a while. So there is a kind of a variant where we use network containers, and I'm sorry here it would be better if I had some schematics, but I don't have the time to put something together. So I will try to explain my insight. The idea is that you start network containers, which are containers that don't do anything except they just exist. They are here and they stay there. They don't run any process. Then you set up those containers using something like PyTorch. So you add network interfaces, IP addresses, you do whatever you want. And then you start the application containers using the --net container option. So you start the application container reusing the network namespace of those network containers. It's a little bit similar to the concept of data containers. When you create a container that doesn't run anything, it's just here to hold data, and so that multiple other containers can say, volumes from that container. Let me reuse the volume of that container. So here, the same way, we create network containers that are just here as kind of a network foundation layer, and then we run the applications within their network instance. And I have a small proof of concept of that, and well, yeah, to be continued. Exactly, that's because there are overlay networks, underlay networks, and so I wanted to talk about network containers instead, because it's really the same concept as data container. So it's a container that exists just to be connected to the network. That's, and yeah, I was confused recently when I saw underlay, but so. I gave some kind of bad news about the future of PyTorch, and then the guy project is not maintaining it. It's shell. What should we do? So very recently, there were two very interesting proposals for Docker networking, and I'm just dropping here like the issues numbers so that you can check them if you want to. And those are pretty big proposals for a better networking model in Docker. That's it. Thank you. Oh, right, yeah.
Any questions? Karen, you going to share the slide?
Oh, yeah,
Yeah, absolutely. So let's thank Jerome. I mean, it was a very short notice. We realized that. Thank you very much for being here. It was very useful. Thank you. So we're just going to continue our demo just for 5 more minutes. And then there is an extra thing that we didn't announce it before. I'll let you know what that is. So yeah, there's a little bit of a small surprise. So we did this before. We connected OVS and then the Docker. We're going to get rid of Docker now, Docker Bridge, and then use the OVS directly to connect these networks to these containers. I have in both the machines two containers running. I'm just going to. So what this did was to remove the Docker bridge, remove the connection that Docker and OVS had, and now just have the plain OVS. And same thing here. Then let's take the first one. Yeah. Okay. So what I just did was now the container is directly connected to the OVS switch, and I've configured an IP address inside that. I didn't use eth1, eth0. I just configured to have it in eth1. I'm going to do the same stuff here, just to see that the containers talk to each other. Logging into the container. Okay. Sorry. Okay. So the remaining stuff doesn't work. So I need to exit the container, and it. So that's one thing to note about it. If you're running the containers, you exit. You don't have. You cannot go back to that unless if it's the same shell that you use. You could always attach to the container when you started it with a daemon. Yeah, that's right. Yeah. So that's essentially what we had for demo. And there was one question about VLAN. You can run the same connect container script. The third option would be to specify a VLAN tag, and then you spin up multiple containers associated with a set of VLANs. So as part of the README, in the instructions, it's there. You can play around and then see it. So we had Jerome talk about pipework. I mean, when we started looking into it, we saw that there's quite a bit of tools and a lot of open source software that's been working particularly to the networking piece. We have the other one is Weave, which essentially treats all these containers. It creates a Weave router for you to connect these containers and such. You can look at more into it. We have Loris Pack, which gives you multiple options to connect these containers. And then if people who are familiar with codeovers and Kubernetes to do cluster management, with Kubernetes, what you can do is everything runs as a container. Every application that you host runs as a container. It's essentially a container cluster manager. It can take care of your Docker containers. You don't have to do anything that you go and specify for each containers. Other you write your, like you have Docker file, Kubernetes has a file that you can use to configure your Docker containers. A very close associate in the sense to Kubernetes is Flannel. It came up to tackle more like what the question was, network overlays, to create network overlays for Kubernetes nodes. And then what OpenStack has is with Havana release, they created a Docker driver with which can be integrated with Nova. But then the current Icehouse lets you actually create a heap template where you can create these Docker containers. You can specify containers and spin that up. If you want a tutorial, actually we have that. Maybe I'll post it in our website so where you can take a look at it. The other reference for that is Scott Lowe. He has a very good tutorial on that. So you can check that out. Okay, so sorry, Scott Lowe, Lowe. He has good information in his blog, which talks about using OpenStack to create these Docker containers.
overlap to more than a cluster management?
Yeah, it's a sort of complicated. It is complicated in a sense that each one works for different
Use
Uh,
cases.
yeah, that's right. So the thing is, Kubernetes is more like a cluster manager. It comes from Google. Google actually opens it, not Google. Google is now kind of contributing to that and basically. So we have Srini here. Srini is the author for Lotus Pack, and since he was able to make it to this event, we thought maybe he can explain a little bit about why he started with Lotus Pack and what are these set of features that you have.
So it's mostly just an extension of what Sriram showed. So essentially, there was a group of folks that wanted to run different applications and isolate them. And doing that, they didn't want to run a controller-based approach. So in SDN, most people are familiar with running open flow controllers, which let you isolate things to run network virtualization, but they all tend to be very heavy. And there was this group that wanted a really easy mechanism for isolating groups of containers and let them not exchange traffic between each other. So I put together something same as what Firefox did. It's right now mostly a shell script, which lets you create isolated containers, and gradually I'm expanding to also provide support for different interfaces. Right now it does VXLAN, GRE, and rules so that you can actually have a whole cluster of hosts be able to have isolated network virtualization, but all of this without using controlling. I'm very familiar with controller-driven models, and I think if you look at the pros and cons, I think Docker was so simple to use and easy to adopt, and we want to keep the same simplicity, and a controller-driven approach can be potentially a problem here. There can be a distributed approach one could do even using OpenVSwitch because OVSDB has control mechanism. So I'm exploring that. I'm adding some code to it. So maybe in the next few meetups, sometime I'll show a demo of what I have in mind and what we can do. But I think using Open vSwitch for Docker networking is definitely promising. But there are some clearly big architectural choices to do, and I think a lot of the discussion going on is about what should be the default networking. I think there's probably not going to be a common one kind of user. I mean, the folks actually I helped out to deploy what they did. I didn't even think of that use case, and it's just that you'll end up seeing people that use containers for purposes that you didn't explore. So I think that way, what you need is be able to support heterogeneity and be able to have a platform that can support any kind of networking that users want, and be able to orchestrate using a good API and be able to also troubleshoot. To be frank, I mean, with this group, I spent literally about 20 hours just to troubleshoot and figure out where the MTU issue was. So there was an MTU that was causing a bottleneck choke point somewhere, which was leading to throughput drops. And it took several hours to figure that out. So when you have so many different touch points of traffic going from one up to the other and different bridges and different IP table routes, it's not easy. Yeah, shell script probably is going to be hard, but I think there needs to be a good architectural choice to make it work. That's what I'm trying to work on.
It's also interesting to see that Srini's code actually supports VXLAN. It's more like an extension to what we talked about. We established a GRE tunnel between the two hosts. It supports VXLAN, I guess. So.
And it inserts rules so that it handles. You don't need to do the. So typically, if you use the regular Open vSwitch and try to set up GRE tunnel or VXLAN tunnel across multiple hosts, you need to use spanning tree. Using spanning tree in a layer 2 network is something most folks are trying to walk away from. So there are, in at least the option that you will have, if you download and give this a try, you'll see that it inserts rules for handling the multicast and broadcast and unicast so that you don't have to do spanning tree. So essentially, it's all about better performance and being able to have better stability. And actually, when we used to have spanning tree, this group that I work with, even when they brought down a container and brought it back up, there was flopping in ports and things like that. So they wanted to move away from spanning tree. So I think in that case, you need to have something that has some centralized intelligence but distributed enforcement.
Thank you so much for that.
Thanks, Srini.
Just to actually follow up on what Srini said, we are planning to have our next meetup on the 15th of December. We will actually share the venue very shortly. A few folks have been very kind enough to offer their space. we will confirm and we'll let you know. The topics that we will be talking about more are other things, other networking options for Docker networking, which is Weave. How do we actually go about using Weave, or even Flannel if you are looking at CoreOS and seeing how you could use that as your choice of container deployment mode. So we'll be talking about, we'll be doing deep dives on those topics in our upcoming sessions. We'll also be talking about Kubernetes in the session following that, but we haven't converged on the dates just yet. So stay tuned, and if you have any questions, please feel free to ask them, and feel free to mingle among yourselves and find out what each one of you are up to in terms of projects related to containers, because there's a wide cross-section of people here. I think it's great to actually have some kind of exchange going on among ourselves as well. If you have something to share with the rest of the group, please do so, what you're doing with respect to containers, and very specifically with related to networks as well. So it'll be great to hear that.
Just to add to one thing, we talked about hands-on tutorial. The code is hosted. You have the README, which explains how you can set up the Docker, the Vagrant, and run the whatever demo that we saw. If you have any questions, please feel free to email me. I'll be happy to answer. Thank you.
Thank you.
That was our first session.
There's some more pizzas, so feel free to take them as well. Hey.